everybody know we're now recording. If you have any problem with us recording, please, of course, let us know this. Feel free to use the chat to raise some issues. There's quite a lot of material to cover, so I suggest that we deal with some of the questions at the end of the webinar. I think some of the questions will be answered as we go through it. How would I share my screen?
In the Quick Start tab, you have the button Share Application.
I'm there. Thank you.
Okay.
I wanted to simply start by saying a couple of things of the context of the webinar. Welcome, everybody. I'm very pleased again that so many of you have been able to join us today. This work has been taking place under the ISA Action Arena that I've been responsible for the last couple of years. And it relates to, of course, INSPIRE and how we can potentially create a common set of guidelines for INSPIRE and RDF. RDF is seen by us as in this experimental and pilot work as a potential means of taking the knowledge and understanding of data sharing from the spatial world in a wider context of e-government applications, and that's been the fantastic thing. We had as an opportunity working with our colleagues in Digit in the ISA program and now the ISA Squared program. Arena will be soon coming to an end as a project this year, and we've already started other work related to this under the new ISA Squared action called Elise. So the story will end here today. This is actually work that we're taking forward and we'll discuss further. So what I need to be clear about from the outset before I hand over to our presenters today is the nature of the work. So, of course, as many of you know, that sharing geospatial data mainly follows OGC standards, the services that are specified in INSPIRE, and the technical guidelines and implementing tools that we have to explain how to use this. But there's the potential to use other technologies, and the RDF work is an opportunity there. Essentially, what's important about this work is that we have developed a common set of guidelines for people to follow if they're interested in this process. And to test out the feasibility of the approach, we have the pilots that we'll discuss today. But essentially, the process of this work, we're not necessarily changing INSPIRE. We're looking at opportunities to build on the infrastructure, and any formal process of creating new encoding rules, etc., would be discussed with the member states and their officials. So here we have an opportunity to understand the potential of the technology. Feasibility, of course, as I just mentioned, is something that we explored, but with our help from two pilot partners, PwC and Interactive Instruments, we're also trying to understand the benefits of such work. So I will stop here, take up too much more time and really down to the details of the interesting work that we've been doing with colleagues. So Monica, I hand back to you to chair the meeting, and I hope everybody enjoys the webinar.
Thank you very much, Robin. Just practicality, I would suggest Enrique, Bart, and Clemens to share your screen while you explain, because the rhythm you want to follow, and maybe you want to switch to something else just to show, I don't know, some screenshots or something more specific from your work. The slide deck will be shared afterwards. It's just one that has a common flow, but I would propose to organize ourselves like that. So Enrique, if you can start sharing the presentation and start your presentation as well, please.
Let me share screen again. Okay, I think it's now sharing. Can you see the presentation?
Yes.
Yes, fine. So it has been structured as Robin has said before in three parts. The first two parts are presenting the results of the pilots, and the last part is to explain the RDF vocabularies and guidelines. Let's start with the first part, which is a pilot project that Wadatel, with several stakeholders, have developed to address a use case in the area of environment. Essentially, it has been the provision of hydrography RDF services from the national inspired data. This work has consisted in taking the published data from CINIG, the National Geographic Information Provider, and then as it is published following the INSPIRE structure, we have made some processes to extract and transform this data to RDF. Here what we have in this slide is a quick view on the stakeholders that have been involved in the project. As I've mentioned before, the first one is CENIS, the Spanish National Center for Spreading the Geographical Information, who promotes and markets the products of Spanish National Geographic Institute. And their main functions in the project have been to be our data provider with the the Spanish inspired hydrography datasets, and also once this pilot has concluded, they are also interested in the publishing of the final results under RDF. As Robin has said before, RDF is a new opportunity to enrich, inspire the spreading of data, as it is offered as a new way to access the spatial data. Another stakeholder has been the Guadalquivir River Basin Agency. This agency is responsible for the water management in the Guadalquivir River Basin, and their interest in the pilot is to incorporate the RDF inspired services in their internal business processes. So we may have a practical use case of the use of inspired RDF data in internal processes in a public entity. Then there is another stakeholder, which is the Andalusian Regional Government Corporate GIS, which is a responsible entity for the provision of horizontal tools for Andalusian Regional Government. They provide consultancy, they provide tools, they provide services too for all the regional government, and they are also interested in the spread of the RDF guidelines. So all the entities inside the regional government can make feasible the publication of INSPIRE and the RDF formats. And finally, the last stakeholder are we, Wadatel, which are a company for consultancy and SDI and corporate GIS solutions. Many other things, but related with this are the main to highlight. And in the pod, we are the solution developer for the RDF spatial data integration. After presenting the stakeholder, let me explain a little bit about the business case. The business case that we are addressing, we have addressed in the pilot, has been a technical approach for the development, the publishing of the INSPIRE national hydrography datasets. This information, once published, can be used as business information for different actors involved in the environmental management of water, and not strictly water. It can also be used by public and private entities interested in this information, as for example infrastructures, transport networks, and so on. The final objective of this pilot is also to increase, see if it's feasible to increase the use and interoperability of the hydrography, hydrography data, as it can be consumed by non-GIS third parties. This is because we are GIS people. I think we all in the web are RDS people, and we know how to discover with metadata services spatial information, and then we are able to consume via WMS or WFS services. But the purpose is also to offer a different way to access to the data via RDF. RDF is a format that is used in non-specialized GIS environments, so it offers an additional channel to link the information. Okay, so this is also the objectives and the business case that we have dealt in the. Now in the next slide, we have a very brief overview of the process that we have followed to provide the information from the NIC to RD services. These are bullet points, but inside each bullet point there are a few activities that we can explain now, or if you're interested in later on in the questions. Okay. The first thing, the first task has been to identify and harvest national inspired data. This data, this hydrography physical mode, is published by CENIC via WFS services, and it is accessible via these services. So the first part has been harvesting this data. Once this harvesting has been made, the second part was to double check if this data was inspired, let's say inspired compliant. This is because it is a lot later process matching the data to the RDF vocabularies. In this case, we must say that the information was 100% inspired compliant, and all the data that were published under the WFS was inspired compliant according to the inspired data model. Once we have ensured that the inspired data model inspired information regarding the hydrography information. I'm sorry, I'm hearing some echo. I don't know. Okay, for now, sorry. We have ensured that the data model is inspired compliant. We have used the RDF guidelines and the vocabularies for inspired that have been built there, and we have made this a correspondence between the data that we have and also the RDF vocabularies. There we must also say the RDF guidelines are properly structured and the vocabularies are let's say perfect. They totally match with the inspired data model. So now these, let's say, third steps, what we have is in the process to build the RDF services is raw data in GML downloaded via WFS services and mapped against the RDF vocabularies. And now the technical process to upload and create the inspired RDF services start. This process, this technical process, has been based in a tool called Virtual. I'm sure that you are familiar with, or at least have heard about it. It's an RDF server, and we have performed several tasks to load this information there. The process, well, some of the difficulties have been in this technical process. As we will see later, the information in the internet is very spread, and the examples sometimes are very old and do not work in a direct way. So part of the pilot has been dealing with these technical difficulties and also collect them to enrich the guidelines. So in some way, all the difficulties we have faced, we can be addressed later in different if they are incorporated to the RDF guidelines as an example or as a separate use case, you can make advantage of these difficulties. Basically, the process to translate from the GML to Virtuoso has been to create an ETL process using Kettle. I'm sure you're also familiar with this, that transforms from GML to Turtle format. This process makes a one-to-one relationship between the data and finally produce a TTL file, which is a kind of XML that can be loaded into Virtuoso. As we have commented, there are different ways to load this RDF data into Virtuoso, but we must say that we have tried those other ways by creating meta models or using the internal Virtuoso database, but we have not succeeded because of the management that Virtuoso makes of the spatial data with the spatial field in these other ways to load information. So the one that we recommend, we recommend that have succeeded, is loading TTL files. Okay, this is an issue that we will comment later on in next slides. And finally, once we have produced the turtle files to load to Virtuoso, then we have published these RDF services via the Virtuoso interface. So it has been this one has been, after all this, it has been a straightforward task. Virtuoso deals very well with turtle files, and we have had no problem there. So the final result has been RDF services of national inspired hydrography data provided by Zenith in RDF format. So any entity can link their data to the inspired data via RDF. Now, once the process has been described, we can go on with this we have faced and the solutions. The first issue we have commented in the previous slide is the technological implementation references that have been able to find in the internet, over the internet. As we have commented, there is not much documentation, and sometimes it's very outdated and doesn't work with latest versions. So what we are proposing here to tackle these issues is to provide you with information, to make it public with the process we have followed. So in case that you want to publish RDF data, you may have all this knowledge at your disposal. And then another issue for the pilot, not for the pilot itself, but for the linking of RDF data and inspired RDF data, has been extracted from different stakeholders that we have been talking with and so on. And it, let's say, a lack of resources and priorities to incorporate these RDF services in their internal processes. When we are talking about resources, it's not only or it's not always a thing about money. It's also about knowledge and making information available. So this is why I think that this pilot addresses this issue, making the results, the informations with this webinar, for example, and also publishing the information, making this information and all the knowledge more available. So any entity that wants to incorporate our services can make it. And another way to improve or to try to involve public entities in the use of RDF as a way to link their spatial data with non-spatial data is to try to enrich the cases that we have addressed in pilot, so they can perceive the RDF benefits. Okay, so as we have said before, it's not a way. RDF services are not a way to substitute anything, but a way to a different channel that tries to make life simple to everyone. These have been the main issues that we have faced in the technological and in the business area, let's say. And finally, we want to conclude with the benefits of the Inspired RDF. Well, it's well known by everyone, but we have tried to validate it in this slide. As you know, it provides a solution that enables you to link spatial and non-spatial data. RDF is very common. It's a very common way to publish RDF. To publish non-spatial data, and by publishing spatial data under RDF, it's enabled to via SparkQL and making of hubs, let's say, to link that data. And we can make the information more available, not of spatial, but link it to the non-spatial. Another benefit that we have perceived, it's quite evident, to publish the geography data in a more extended format in the World Wide Web. What I mean is to make it understandable by non-spaced GIS users. RDF is very well known, and WFS is very technical. It's not good for GIS user, but it is for non-GIS users. So publishing under RDF enables to link this hydrography data to more, let's say, more target audience. It can also be indexed in machine-to-machine searches, so we can make it also improve availability of the data in that way. It's not a direct thing because as Google doesn't find an WFS query, it doesn't find RDF services if you do not specifically publish each entity, let's say, inside a web page. But once it's published in a web page, the locator, the identifier of entity under RDF, it can be linked to web search engines. It also Inspired RDF. It's also enables the use of existing tools. As I have commented before, RDF comes from years ago for the non-GIS public. So there exists a set of tools to process data, and portals have RDF plugins, SparkQL queries, and things like that. So there already exists tool to explore this information. And finally, as it is make it available by an identifier, it can be reused for another non-specific use than only hydrography. I mean, for example, floods and for example, planning, transport planning, as we have said before, network planning, agriculture, or even reporting purposes in the Water Framework Directive. As this information can be published, it could be harvested or used to make a WFD report. So I hope with these slides, I hope that our pilot is more or less clear. I know there is a lot to talk about. As we have said before, we will be very pleased to answer any question you have. So from our side, I think it's all, and I'll let Bart from NetEase to go on with the presentation.
With some questions that you would like to ask Enrique about what he explains, you can either click on the hand that you have close to your name, or you can write it on the chat. Okay, we can continue with NetEase. Bart, can you share your screen, please?
First, unmute myself. Can you see my screen? Okay, now.
This is Edit.
Actually, we were so our pilot was about improving the information position of emergency responders with Spire data. This pilot is done mainly by us, NetEase. We do data for smarter firefighters. We've been in business for more than 20 years. We have working with fire departments for more than 10 years now. And recently done a lot of linked data work for fire departments. So we are not a typical GIS company. We do GIS, but it's not our main focus. We are more on interconnect data and connecting data. The two unofficial partners on this project were the Dutch Cadastre, who are very interested in seeing use cases for their work they're doing with exposing all data as RDF. And with the Institute of Physical Safety, which is a supporting organization for the Dutch Fire Department, who is building a reference object set for building fire services in the Netherlands. It's the fire service base registration objects. And the idea behind that is to combine various public and private data sets to generate a contextual image for fire service, both in preparation, prevention, and operations. Is that what the force is interested in about certain locations, about buildings, and we focused mainly on this in this pilot. But the new registrations in the Netherlands is that, for example, the wind turbines are in buildings and are in different registrations. We left them out specifically just to sort of narrow the scope. We used one city to do the project because the amount of data it would generate, we had to reiterate over all the data sets for a bit. So the situation is that the fire service depends on a combination of data from various sources to build a complete image which is interesting for the fire service. A lot of the base registries in the Netherlands or other more or less traditional data sets which are available about the public space in general only cover one aspect of either a building or a company or an address or a dwelling. The combination of various features from those data sets is actually what makes it interesting for the fire service. So we're interested in building size, the type of businesses that are registered, the type of activity allowed, and for us specifically HAZMAT, which stands for Hazardous Materials Indication. People have permits to store combustible fluids or gas or high pressure gas or anything on their property. And besides that, if we had an incident, or if we are developing a preparation plan for some locations, it's interesting to know what's around it as well. And then you need a combination of bit pieces of information from those data sets to generate a complete image. One of the problems, obviously, is that the fire service has no authority of any of this data. We need to rely on what others give us, and we also do not have the technical means, nor the financial means, to build those data sets ourselves. I think that is exactly what open data is for, that we should be using shared data. So what the problem description is that we figured out there is a combination of inspire and non-inspire themes. So if you talk about locations, and you go addresses, buildings, dwellings, parcels, etc., that's all inspire themes. But for it gets interesting, some registrations which are linked to those inspire themes, who lives there, which companies are registered, what type of permits are allowed for a certain building, which type of permits are actually granted for a building, or what type of check done on certain buildings, etc., etc. These are all items which actually relate to inspire themes, but are not inspire themes by themselves. So you can talk property tax registers, company registers as registrations, and locations as addresses, buildings, parcels, etc. And one of the other issues we found is that what is a object to us, which is a building or a dwelling or a production facility, is actually present in various inspire themes. So it could be the parcel which owns a permit or which has a permit. It could be an address where a company is registered, or it could be a building which has a certain usage case. Which means that all these data sets, these registrations, could be on various levels of the same object within various registrations, which makes it very hard to enact everything. So you could, for a company, you could have a company register saying something only about the address, where the permits are actually on parcel or on building level. And how do you kind all that? Relations actually go, well, there is a company registered at a certain address, but also in a certain building, which is more and more complicated. The current method to get the data set is basically draw a pin through a map, and everything that's stuck through the various map layers with all these pieces of information belong together. Everything that sticks to the pin you push through the map should be related to the object you're talking about. This needs has a couple of specs. It's computing intensive, so you need to do spatial computing for all the data they have. It's quite a bit amount of knowledge to actually build this data set. You need to be very well known in schools, where, because of the Netherlands, we have our own coordinate reference system, but also some of the data sets use just the WGS84, so you need to incorporate that kind of stuff. Only relation you'll find is that it's to the same location, but if this party and this permit are registered at the same location, actually have a certain relation, so the semantics of that relation is completely gone. Use of authoritative identifiers. And one of the things we found in several test cases is that non-spatial relations are missed. If you have a company who has subsidiaries across the street, you will miss them because they are not spatial related. It would be very interesting to know that they're there. One of the examples we have is that there's a fire in a apartment building, and on the ground floor there was a child daycare center. The child daycare center was evacuated to the closest other child daycare center. Nobody had any clue who the kids were. If they have known that about 500 meters away there was a subsidiary of the original child daycare center, they probably could have bring the kids there and would have prevented all the hassle of figuring out who the kids are. So what did we do? We converted the data to RDF. We tried several things. We start working with Google Refine to get this going. But that figured out that there is so much data that actually using Google Refine is not sort of going to work in the long run. it helped us reconstruct the initial data sets, but not doing it in batch format. So in the end, we started writing our own tool to large-scale data set conversions. We figured out what the identifiers would be. We mapped addresses to official Inspire address IDs instead of just address strings. And we had some help of the cadastre to find the relation between parcels, buildings, and addresses. And then we mapped all the registries to the descriptive fires. The Stardock database to do this, we've got a nice contract with Stardock to do this. But when we converted all this data, we needed to sort of create a reference object which controls the links, because one of the things we wanted to do with this project is the original mashup had no metadata in any form. And with the RDF model, we are able to say, okay, we can keep metadata at data set level or at data resource level. So we know when a register is updated for a specific company or for a specific address, and reflect that in the resulting RDF object or resource, which represents the fire department's object. This, it's very easy to query for which objects in the company register have updated since the update on this fire department object, and we can simply update a single instance instead of rebuilding the current full data set. And that's something that's being done right now all the time if they want to rebuild the data set. Sorry? These we figured out, obviously, even with one city, it's huge. The interesting thing is we found there seems to be a missing theme in Inspire, is that dwellings, which is used by a lot of the registrations we have in the Netherlands, but we have no real object to relate it to. We are very happy to find some possibilities to link provenance of the various objects, and a bit more semantics in what the relations actually mean and how how the various things relate to one another. I think that's about it. I think, and sort of underline the statements made by Quadatel on the knowledge of RDF and the problems that causes with the partnering organizations. Cadastre is pretty well up team with their RDF knowledge. They're very knowledgeable, but from the fire department side, that's a large path to learn that. But they have similar problems with all the GIS toolings.
Okay, much, Bart. Any questions in this regard for Bart? Doesn't seem so. If you come up with anything, please write it on the chat, or we can go through a question at the end. So, can you continue, please?
Can you see my screen?
We don't.
Yeah. It's me. I'm sharing my screen.
Okay, we can see.
Okay. All right. So the third part of this presentation is very different, because you've heard from Quadatel and Netage about pilots where they were using Inspire and RDF together. And our task in this context was to prepare that so that it can run can be run, let's say, using the same RDF vocabularies, etc., etc. So our task in this was to work on guidelines and RDF vocabularies, and I'm going to explain that a little bit more detail. So the idea was, the idea is just we have the Inspire data specifications, and they have the semantics, so basically the object types and their properties, ML, and then we have derived GM application schemas are consistently used then encode data, and as explained in the beginning, to see whether RDF encodings, so typically Turtle, could also be JSON LD or RDF XML or any of the other RDF encodings to support that. The goal was to develop Inspire vocabularies, and that's what we did. We do it for all the themes, but we focused on that were used in the pilot, so the high themes that were used in by Guadatel, and the other buildings, cadastral parcels, addresses, administrative units, etc. that were used in the Netherlands by Netsch. The base for this work that we did is actually in the implementing rule for the interoperability spatial data, regulation 1089 from 2010, which basically requires that we develop an encoding rule for that, and that's what the guidelines are. But the goal is to take the information that we have in the data specifications and the implementing rules and create RDF vocabularies. And that approach, so we wanted to test it in the pilots, get feedback, and then basically develop new versions based on feedback that we have got. As Robin has explained in the beginning, this is not to replace or supersede existing specifications or encodings, but it has to see whether that's an additional optional encoding and what the benefits of that are. Guidelines itself are actually required basically by Article 7 of the implementing rule, and because that states that you have to specify, if you're an additional encoding, it needs to be clear how the semantics that are captured in our models, the data specifications, and also the implementing rule, they map to an encoding, so that if the data, you can understand how it relates to the Inspire requirements. This is really what the guidelines are about. We'll have a look at the document later on. That was done basically over the last year, built actually on a project also from Arena from 2014, and that discussed the approach where several experts were involved, and the basic roadmap on how to do it was developed, but identified a number of issues, and so we kind of discussed the issues and came to a preliminary proposal that we wanted to test. And basically, the idea of this activity is to have a draft of an rule that could be ready for stakeholder review, basically another guide document, draft for another guidance document, and that's basically what we will be doing, taking into account feedback that we have from the wider community and also the pilots. The key chapters really of this, the structure of the document is a bit, you have to be used to that, but basically the structure is really given by the ISO standards about encoding rules. But the important part is that we actually look at coding on two levels. So one of the things, the main part is actually that we're looking at, so we have the Inspire datafication and the UML models. That's basically the schema conversion. How do we convert those to RDF schema and OWL? So we have to tackle how we deal with application schemas, with the types and the properties, in some cases also association classes, constraints, etc. So the elements that we have in the UML models. The second part is then the instance conversion. So if I have an object in Inspire, there are, besides, let's say, the schema aspects, there are also a few other elements that we need to look at, which are resource identifiers, the discussion whether we look at it from a, is it the data that we're looking at, is it something that represents the real world entity, and what's the role of the feature or spatial object in that context. And there are a few other topics where the schema doesn't really specify everything, and where we need some additional guidance on what to do in instances. Let's have a quick look at the resources that we have. So everything that we have done is basically in GitHub. So we have two GitHub repositories that are there in the slides. So when you get the slides, but probably when you put it in Google, you will find it as well. So we have the guidelines as one repository, and one repository with the vocabularies. The guidelines are here in the repository, but they're also available as a GitHub Pages document, which is compiled from in that repository, and that has that all information that is required by an encoding rule. We see here on the left side the table of contents. So we have the schema conversion rules that basically requirements on how to convert the schemas, and that's these requirements or these process that is described in here. That's what we then have applied for these sample themes like adjusted parcels, buildings, hydrography, to create a draft Inspire RDF vocabularies for the themes. So we have information about the pages, how we deal with that. That is and there are also, you can see some issues. I'll get back to that. So we have a number of issues, and they are linked from that document. We have information in here like how we map, let's say, the types from the ISO standards, how we represent that data in RDFS, OWL, including also the geometries, etc. And then we also here have the instance conversion rules, where we basically have guidance on how to deal with the resource identifiers, etc. So that's basically this part, and let me also quickly look to the Inspire RDF vocabularies repository, where you can also find some information in here. And if we go to let's say to administrative units, they're held basically per application schema with information how it is actually was mapped from the UML model. That is fully documented, and then you see empirical information, for example, about the administrative unit spatial object type, which is a feature, so that's a geospatial element, and these the RDF vocabularies that Atal and Net have been used. As mentioned, we also have some issues, and also you can see also that's, for example, an issue that has created based on their work, where he was looking for things, additional mechanisms that are currently not present, and that where we then use GitHub to openly discuss the issue, and basically going back to the presentation. All the development work is done openly in GitHub. We have feedback not only from the pilots but also from some others from the community that added comments or new issues. And basically, the process that we're going through now, as Robin has mentioned in the beginning, the project is going up. So basically, we're updating the issues and guidelines and also the vocabularies to take into account feedback and the comments that were received and that we done during this month. And then we do have these resources, and then they will be final, right? Because that basically represents then seeing there's still these issues, and I think for a wider community review and stakeholder review will be required, but that is then potentially ready to go to the next steps. And I've also included the link to the resources on GitHub. And with that, I'll pass back to you, Monica.
Clemens. There was a question about if this documentation and some other technical documentation was going to be made available. We are going to publish this material, and therefore I would strongly ask you to provide me with your emails via chat. In this sense, Robin, would you like to comment anything else?
Quickly give a very quick tour of some of the things that we have available. We made some pointers to other work, so I will just quickly share from here. So it's on the screen. Hang on, there we go. We have for some time now had a space on ISA's JoinUp platform where a lot of the RDF work has been presented. So I'd also make mention that our previous work, as Clemens had said, we'd started to explore this topic a couple of years ago. And in the meantime, we were also the project that contributed to the development of GeoDCAT AP. So here was more a linked data view on metadata. Of course, is now focusing more on datasets. So if you go into JoinUp, you'll find some history and find some of the activities there. And what we'll do as phase 2 activities, make links to these presentations today, hopefully also the recording of the session, and you can follow up as well. Just to give you a couple of words on documentation, working with PwC and interactive instruments, we've tried to look at a way in which we can help document how people are taking different approaches to implementing Inspire anyway, but also we're taking some view on how we could potentially document how to use Inspire. And we've used the opportunity of these pilots to do some of that work and to start to document things. So Enrique, for example, has volunteered to try and look into this process, how we can share some of the practicalities of what he's been going through and identify again some of the benefits so that people can learn a little bit more where we are in the process. So thanks to our colleagues in Norway for raising these issues. We hope to share again the outputs of this documentation partly through JoinUp, but also ideally through our Inspire and Practice platform that's part of the Inspire knowledge base and website. Elements I just wanted to briefly mention is some of the continuation of this work, building on spatial data infrastructures and making data more available on the web is the ongoing work of the ELISA action, and similarly on JoinUp we'll be shortly providing some details of this work. I done partly work in the Netherlands from Geonovum and looks again into more, let's say, the Inspire perspective. So those of you who are interested in this topic in general, it could be interesting if you want to stay in contact with us to either contact us through the Arena email address for now, or if you prefer, you can put your email address in the chat. We'll send you some updates of how we're progressing on these activities. We're going through a process of trying to explore the benefits of the activity in a little bit more detail. Annika and colleagues, Jens, for example, we were having a discussion yesterday with the Dutch Kadaster, and a request from that particular activity was to really see where we have opportunities, as Enrique said, to exchange knowledge around this topic. So the Dutch Kadaster have started here. They know there's some work going on in Ireland, and they had some meetings, but it would be interesting from their perspective to maybe exchange some more ideas and evidence on this. And particularly I would underline, as Enrique said, as we're starting the process to look into the topic and to have a critical eye, of course, on where the benefits really lie. It would to know if there are other examples out there. Just so you know, underlining, of course, that there is the GitHub pages that Clemens mentioned already, and you can get to them here also through GitHub. But we will also try and present the final results of this work at the Inspire conference. I would just like to close with one other interesting comment that Enrique made. We're doing many things under the Arena project also as we're moving into Elise. And one of the things that he mentioned as a step in his process in going through the data was checking about whether the data was actually compliant. Yesterday, we had a webinar showing some of, again, with the support of interactive instruments in PwC, how we validate Inspire data. So there will, to let you know, there's also a webinar recording from that work that you might be able to pick up from this activity, also through JoinUp to find out more about the other work that we're doing on validating Inspire data. So I'll just stop sharing my screen now so I can just check the chat. And I also, there was a question from Martin, although I'm having difficulty reading exactly in terms of chat messages. So Martin says, for the pilots and RDF vocabularies and guidelines, a few questions. So what is the plan for the maintenance governance of the existing and further development of the vocabularies? Remaining themes. So we've gone through this, let's say, experimental phase. I think what's important in the first instance is to have a discussion with the MIG, so this is an implementation group of Inspire, to understand if the direction that we've taken here is making sense to member states. That's already a first step. But then we have to understand if there's demand to go in this direction to explore RDF further. The nice thing about the pilots, I think you've seen, is that they've taken two quite different perspectives. One maybe more building on a data provider perspective in Spain, and also maybe more a user perspective in the Netherlands. Of course, they're complementary activities, but I think this gives us a little bit of a rounder view on what we're doing. So if Michael's available at the moment, I would ask him if there's anything foreseen in the MIG processes that we could maybe hear today more specifically. I don't know if
Thanks. Yes. Thanks, Robin. We haven't really planned anything yet. We wanted to use this webinar as a first instance to make the MIG in the first instance and the MIG in general aware of this work, or more aware of this work, and basically I think the main thing that the MIG might be interested in, as I wrote to them as well, is basically the work on the encoding rules for RDF, because we have in the MIG able to start working on additional encodings to simplify, let's say, the data exchange and the implementation of the data interoperability implementing rules, starting probably at the end of this year. And I think the work that Clemens and colleagues have done on the RDF draft encoding rules is a useful input to that discussion, not only for the content, let's say the RDF specific case, but also as an example on how to do an alternative encoding rule for any kind of additional or alternative formats that we may want to discuss in the MIG. So I think any, let's say, formal further follow-up of this work, I think, should sit under the proposed action to come up with alternative encodings.
I would also turn to Martin's second question. So for currently missing ontologies, is it possible to use other ones available on the scene, for example, W3C's ontology was mentioned here? And what's the main difference, pros and cons? I have two views on this. If anybody from the projects wants to comment on this, feel free. But this may be a good example of the type of question we could put on GitHub. Is there anybody who would want to comment on that? Maybe Clemens, do you have an opinion?
You can comment on that. So basically, I think when there are other themes, I think what we use is the work that that Phil Archer and others did in that project, which he published on the W3C website. We all looked at that, and I think what we have done is consistent. Basically, also Phil Archer, when he drafted the vocabularies for that European project, so that was a European project that which they also encoded some Inspire data in RDF. That building partly, and in the documentation there are references to the earlier ARENA project, and we also looked at the results of that project when we were going through the open issues for the draft. What it certainly isn't, I mean, strictly if you use any of that, it isn't really compliant. If you're about compliance, it isn't really compliant with Inspire, because what it doesn't have is an encoding rule that clearly states how the information is mapped. So the idea really would be, and to see that was from a project and basically publishing results. I think the idea would be that we'll take other influences. Maybe there are other activities which we are not aware of. In the issues, we have also links to that project that we take into account, and basically that this is fed into the process, so that if it will publish at some point RDF vocabularies, that these basically represent the consensus of the wider community. That's my view on the second question. Regarding the third one, while I did, what is also, I mean, I also was an active member in that spatial on the web working group of W3C and OGC, and I think what we've done is actually consistent with the best practices that we have now, and potentially there are more synergies, and that is also related to a question that I think Peter Andersen added later on. So I think part of the work that the spatial data on the web working group was working on, and that we ended last Friday, the working group finished W3C, but there will be follow-on activities, and some of the topics we don't really have a clear representation. We do have something for geometries and for the simple types, but look at coverages or options, that it's not that clear. But that working group was working also on a typology that is pretty advanced. Also, there is a draft for cell networks and observation ontologies, and also work on coverages. Particularly as the work progresses, we get more building blocks that are currently missing, where they're renting a consensus in the wider community, how that should be represented in an RDF context. There are also, I should mention, for the Inspire TC211 data types, the TC211 also publishes ontologies for all the ICE model, I'm not convinced that these are representations because they are really the UML legacy or background that they have. So I think in many cases they also don't really represent or there's representations of the UML models, but in many cases there are existing RDF vocabularies that overlap in semantics, and the view we take in the guidelines is that we should be reusing existing vocabularies. For example, Prof O for print information is an example, and we believe that if we go to RDF, that should be used and not the ISO 19115 list metadata. So I think there's more work that is needed, but it's ongoing, partly as a spatial data on the web working group, but potentially also other activities need to complement that. I see there on OCL. Did we do anything with the OCL? No, I think we
just encoded a property in the vocabularies,
yeah,
the description of an OCL constraints, but it's not like we have any validation.
So one of the issues is also whether we should be using Shackle or something. When we started, that was a draft, but it's maturing now, and that's certainly an option. But it's to an extent that also depends on for what it should be. I mean, what's the role of the vocabulary? Does it go that far that you really want to validate data against that, or is it mostly that you can use and express the data in RDF and use it in other cases in which the schema information or the quality constraints or other constraints aren't that important? I think that's clearly an open point for discussion in what these vocabularies should be about. Basically, so far we have taken the view that it is really for validation, but again, that's open for discussion. Right.
There is another question, maybe for Michael and Robin. If there are any plans to convert ISO TC 211 data types?
What I was referring to in the last discussion. Basically, there are activities that are ongoing that look into that, but basically, as what we're reusing is where there is a standardization activity to do that, and that results. But we should be knowing that blindly, but see where we can reuse existing vocabularies. So, for example, for geometry and the feature representation, we've been using geospatial from OGC.
I haven't seen any more questions.
Stefan, regarding constraints via OCL and comparison with RDF. Are you again aware of anything regarding this topic?
Well, I was hitting on that one. That was the Shackle discussion. So, and where the vocabularies are about or more about expressing the semantics, and so there is an open issue, and we haven't had any feedback so far on that.
That fills a gap for me, so thank you very much, Clemens. I would just also like to highlight the comment made by our colleague in Eurostat, Hannes, where he's mentioning some of the work they're doing on NUTS RDF. I think it's a thing that they have, of course, this ability to link to some of their data too, and of course, we could look at opportunities in the future, how we can bring some of our findings together. I'd also like to reiterate something I mentioned at the beginning, that the work that we do in RDF is alongside some work Clemens and colleagues are supporting us on, also from PwC, related to spatial data on the web work of particularly via Novum's projects that we're undertaking in the ISA action. And again, I would invite people, if you can either put your email in the chat or send an email to us here at this address, be able to touch upon this. Yeah, thanks, Hannes. So basically, I'm conscious of time, but I would give still the chance for some people to raise some questions now. Basically, would also ask if any of the presenters have any questions for each other too, for that matter. That's not the case. I think I take the opportunity to only overrun slightly with the time. I want to thank very much all the presenters for the interesting activity that they have been doing with us for a few months and longer, of course, in some cases, in helping moving this topic forward. When we started the work on RDF a couple of years ago, we also wanted to try and test something out in practice. And apart from anything, we really seem to have achieved that objective. I appreciate that this is the starting point also of a wider discussion. Again, we'll take that fully through with the member states, as Martin highlights here within the MIG, and use that opportunity to try and disseminate and share knowledge further. So as a follow-up to this anyway, we'll get your email addresses, and we'll send you some very specific questions around if you think there may be some interesting activity to share with a wider group related to work in organizations and countries. Okay, so from my side, I have nothing additional to add, and I'll just hand back to Monica now to close proceedings.
Well, as Robin said, if you want us to get in touch with you and share to share all the documentation, please leave your email addresses in the chat. I have already seen that many of you have included your email, so thank you very much. The material will consist of the proper webinar that, as I told you before, is being recorded, but also the slides and the access to the guidelines that Clemens explained. So just at this moment, I would like to thank you all for your attendance and to see you in next activities.
Okay, goodbye. I'll keep the webinar open so that we can collect any remaining email addresses. Thank you all.
Say bye-bye.